On June 28, 2009, a party was thrown at the University of Cambridge. There was champagne, hors d'oeuvres, and a banner hung across the room. The guest list, however, was highly exclusive. It was strictly for time travelers. The host of this gathering was theoretical physicist Stephen Hawking. He set up the room, chilled the drinks, and sat by the door waiting for anyone from the future to walk in. But the experiment relied on one crucial catch. Hawking didn't send out the invitations until the day after the party was over. The logic was precise. If time machines are ever invented, someone in the future would find the invitation and travel back to the correct date. Yet, as the clock ticked past the end of the night, not a single person showed up. For the engineering-minded skeptic, this zero result is the final nail in the coffin. If future humans can travel back in time, we would have seen them by now. The empty room suggests the technology simply cannot exist. But theoretical physics tells a different story. If we look closely at the complex equations left behind by Albert Einstein, the math clearly shows that time travel is entirely possible, and it is happening right now. To reconcile these two facts, the empty party and Einstein's math, we have to discard our everyday perception of the clock. We need to look at the mechanical structure of the universe to see exactly why it issues a one-way ticket to the future, but strictly enforces a ban on returning to the past. For centuries, humanity understood time through this vintage architectural blueprint. Proposed by Isaac Newton, time was a straight, rigid arrow, flying forward at an absolute pace. Whether standing on Earth or flying through the cosmos, 1 second is exactly 1 second for everyone. Time was thought to be an unchangeable arrow flying forward in the background of reality, entirely unaffected by the physical objects moving within it. That mechanical view of the universe held until 1905, when Albert Einstein published his special theory of relativity. This diagram shows Einstein's correction. Time is not a rigid arrow, it behaves like a flexible rubber band. It can be stretched and compressed. You already experience a psychological version of this. Play your favorite video game and an hour flies by in what feels like 5 minutes. Sit in a dull lecture and 5 minutes drags on like an hour. Physics mirrors this flexibility through two specific levers, speed and gravity. Einstein realized that because the speed of light must remain the same for everyone, the universe has to cheat somewhere else to keep the equations balanced. Since light speed is the only fixed constant, time itself must be the variable that stretches or shrinks. This revelation transforms time from an abstract ticking clock into a physical, localized dimension that can be manipulated. Let's test the first lever, speed. In physics, this effect is known as time dilation. The rule dictates a strict trade-off. The faster an object moves through space, the slower it moves through time. Let's set up the classic twin paradox. We start with two 20-year-old brothers. Twin A stays on Earth, while Twin B straps into a rocket. The spacecraft launches, cruising at 99% of light speed. Moving this rapidly through space slows his progression through time. Inside the cabin, he experiences just 1 year. When the ship lands, his brother is an 80-year-old man. 60 years elapsed on Earth. The spacefaring twin has mathematically time-traveled 59 years into Earth's future, without aging the same amount himself. These theoretical calculations have been verified through actual recorded data gathered from the edge of our atmosphere. Meet Russian cosmonaut Sergei Krikalev, recognized by physicists as the world's first official time traveler. Krikalev spent a cumulative 803 days living in space stations orbiting the Earth at roughly 17,000 miles per hour. That prolonged exposure to orbital speeds subjected him to physical time dilation. When he returned to Earth permanently, he had arrived exactly 0.02 seconds into his own future. However, scaling this up presents a massive problem. Accelerating a human-rated spacecraft anywhere near the speed of light requires energy outputs that dwarf the entire power generation of our planet. The fuel requirements alone make the engineering impossible with current technology. Traveling to the future using extreme speed is mathematically proven and physically real. The only thing stopping us from jumping a century forward is the limitation of human engineering. If we lack the fuel for speed, we can look to the second lever of time manipulation, gravity. In his theory of general relativity, Einstein proved that massive objects warp the fabric of spacetime. The more intense the gravitational field, the slower time flows for anyone caught inside it. The extreme example is a black hole, where a collapsed star creates a gravitational well so deep, it bends the spacetime grid violently inward. If you've seen the film Interstellar, you know the math. Approaching a supermassive black hole means time slows down so drastically that 1 hour near the event horizon equals 7 years passing on Earth. Maintain that orbit for one subjective year, and by the time you return to our solar system, centuries will have passed. You will have survived into the distant future. This gravitational time warp happens constantly on a microscopic scale. Earth's gravity is slightly stronger at the surface than it is higher up, meaning time literally passes at a slightly different rate for your feet than it does for your head. But once again, biology gets in the way of physics. Attempting to harness the gravity of a black hole to time travel is a lethal proposition for the human body. Astrophysicists call the process spaghettification. The gravitational pull on your feet would be so much stronger than the pull on your head that the tidal forces would stretch your matter apart into a thin stream of atoms long before you could experience the time jump. Extreme gravity provides the most powerful engine for forward time travel in the known universe, but ultimately, the physics confirm that you will have definitively arrived in the future. Skipping ahead into the future is a matter of surviving extreme forces, but what about hitting reverse? The ultimate fantasy is traveling backward to fix a past mistake or alter the course of history. The moment you attempt to move backward, the universe actively resists. Returning to the past violates the most rigid, unbreakable rule of nature, causality, the law that every effect must have a preceding cause. This flowchart breaks down the ultimate logical failure of backward travel, known as the grandfather paradox. You step into a machine, travel back several decades, and accidentally eliminate your grandfather before your parent is even conceived. The cause and effect chain shatters. If your grandfather is gone, your parent is never born, so you are never born. The logic implodes. If you were never born, you couldn't build the machine. If you don't build the machine, your grandfather lives. Mathematics provides one escape hatch for this loop, the multiverse. Altering a past event doesn't overwrite original history. Instead, the moment you make a change, the universe splits, creating a parallel timeline while leaving your origin reality intact. However, parallel dimensions remain entirely hypothetical. Without empirical proof of a multiverse, we are left with a universe that appears to actively protect its internal logic by making the past strictly and permanently inaccessible. The verdict from theoretical physics is clear. Traveling to the future is a measured empirical reality waiting for better engineering. Traveling to the past is a logical paradox forbidden by the laws of nature. But Einstein's concept of relative time extends beyond the intense gravity of black holes and the velocity of rockets. It operates deeply within human cognition. At present, the only working time machine on Earth is the human mind. We are uniquely capable of projecting our consciousness across the timeline. We routinely visit the past through our memories to gather data, and we shape the future through our imaginations to build a better reality. So where do you stand on the physics of time? Do you believe the multiverse theory provides a valid mathematical loophole to travel backward? Or do you agree with Stephen Hawking's empty party, proving the past is permanently closed? Let me know your verdict in the comments below.